This is the review that we did on the gray papers around the room. Um, the first one says, find the 99th term of the sequence. So if we want the 99th term, that means that we have to use the explicit form. And in this case, 9 to 12, 12 to 15, and 15 to 18 is adding 3. So we need to use the arithmetic form, which is f of n equals f1 plus m n minus 1. So the first term, so f of n is equal to the first term, which is 9. It's adding 3, and then n minus 1. N is the term number, and since we want the 99th term, we're going to put 99 in for m, n, and so that's going to be 9 plus 3, and then 99 minus 1. And if we actually were to do that, we would end up with the number 303. The next one we have, after 1 month of living in her house, April has 3 cockroaches. After 2 months, she has 48. 3 months, 768, and so forth. What's the explicit form? So if we're going from 3 to 48 to 768, well, if it were adding, it would be adding 45, but that doesn't, but 48 plus 45 doesn't give you the next number. So it has to multiply. And if you try some different numbers, it ends up multiplying by 16 on both of those. And that actually is what cockroaches multiply by. So in this one, we're writing geometric. So geometric is Fn equals F1 times 3 to the n minus 1. It's timesing, therefore we need an exponent. So we're going to have Fn equals, the first term is 3, and then we're timesing 16. Since we're timesing, it has to be an exponent n minus 1. And it just wanted our explicit form, and that's what we have right there, and so we're done. This one, find the recursive form of the sequence. So we have to figure out what is this doing in this sequence here. 1 to 6 would be 5, well, negative 1 to 6 would be 7. And then it doesn't go up 7 again, so it's not adding. So it has to be multiplying, and on this one it's actually timesing. So a negative 1 to get to 6 would times by a negative 6. And so it's timesing negative 6 on all of those. So the recursive form of geometric is Fn equals r Fn minus 1. We found our r. Our r is that negative 6 number. So if we were to plug that in, we would have Fn equals negative 6, and then we just have Fn minus 1. We don't have to put a time symbol in between the negative 6 right here and the f because that's implied. It's just already there without us doing it. The common difference D of the arithmetic sequence, so from 8 to negative 2 to negative 12 to negative 22, well, it says it's arithmetic, therefore it must be adding or subtracting. Since the numbers are getting smaller, it must be subtracting, and in this case it's taking 10 away. So our common difference, or the slope, same thing, is just negative 10, and that is our answer. Sally's going to be she's going to eat 2 beans tomorrow, and every day after that she's going to have 5 beans. Write an explicit formula for the, I didn't mean to say minutes, I meant to say for the beans. Sally will eat on day n. So for this one, it says additional, so that tells me that this must be arithmetic. So I need F1 plus m and n minus 1, because that is our explicit form for arithmetic. And our first day is gonna be 2, and then every day we are adding 5, so our slope is 5, and then n minus 1 would be our form. The next one, using the perimeter, what will the perimeter be in the 17th figure? So the perimeter here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Perimeter is just the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it goes from 5 to 8, 8 to 11. That's adding 3. So we want the perimeter in the 17th figure. So we could keep adding 3 until we get to the 17th one. Or we could write a formula. So the first term is 5. We know it's adding 3 and minus 1. And because we want the 17th number, we could plug in 17 for n, and that could also give us our answer. And the answer on this one is 53. So if we keep adding 3 till we get to 17, it's 53. The next one, skipped one. Okay, what is the sixth term of the sequence defined by the recursive rule? F1 is 14 and Fn equals Fn minus 1 plus 6. This means the previous number adds 6. So what we have is F1 is 14. That's our first term. The first number is 14. We want the sixth number, so we're going to go 2, 3, 4, 5, 6. That's what we want to find. And it tells us that the previous number, we add 6 to it. So we're going to add 6, 20, add 6, 26, add 6, 32, add 6, 36, and if we add 6, oh, I added 4 there, 38, and if we add 6 to that, we get 44. So our sixth term on this one is 44. Find the next term in the geometric sequence. So we need to figure out what is it timesing by. Well, sorry, it is timesing on this one. Whenever you've got that negative, positive, negative, it's either timesing or dividing. And it did tell us it's geometric. So I did know it was timesing or division. In this case, the numbers are getting bigger. So it has to be multiplication. And in this one, it's multiplying. 6 to 54 is timesing negative 9. And so the next term, if we take that negative 486 and times it by negative 9, we get 4,374. Which of the following is not geometric? So the first one, this is actually 1/2, right? 0.5 is the same as a half. So right here, I know to get from 4 to 16 is timesing by 4. And if I check that on these other two, it turns out that one is timesing by 4, so that one works. Number B, or letter B, this one, it's actually taking away 1.2. And if you keep taking away 1.2, that's what we end up with here. So this one is taking 1.2. Let's check these. So that one is, it looks like it's timesing, and it's doubling those numbers. So it's timesing a negative 2 on this one. And the last one is just doubling, which is timesing by 2. So the answer on this one is B, since that one is subtracting, and that's not geometric. Write the explicit form of the nth term of the geometric, we know it's geometric, sequence with f of n is negative 55 and the common ratio is 5. So we know 1, 2, 3. The third term is negative 55. It's multiplying by 5 if we're going this way, so timesing by 5. But since I want the first term, because in my explicit formula, I need the first term. So to go backwards here, I have to actually divide the 5. And so that's going to be negative 11. And if you divide 5 one more time, you get negative 2.2. I want make sure that on the test, it's a multiple choice answer. And you need to know how to turn negative 2.2 into a fraction. And actually on this one, so you hit math on your calculator, and then you just hit enter twice. So that's how you change it into a fraction. And if you do that, you're going to end up with the first term is going to be negative 11/5. We know that r right here, r is 5, and so we can write the explicit form of that. So we have our first term is right here. We've got our r, and then because it's multiplying, make sure that n minus 1 is an exponent. An arithmetic sequence have a first term of 4 and a sixth term of 11. Find the value of the output of the sequence is 25. So we got x, y. The first term is 4, and the sixth term is 11. If I find that difference, I'm going to get 7. If I find this difference, I get 5. So I'm going to do 7 divided by 5, which is 1.4. So then I want the output to be 25. I could take 11 and I could just keep adding 1.4. So I know 1, 2, 3, 4, 5, 6 is 11. And I could just keep adding 1.4 until I get the 25. Another way to do this is, since the first term is 4, and I know my slope is 1.4, and then n minus 1, since it was adding, I can just plug in numbers for n to figure out what works for the 25. So on this one, it turns out to be 16, no matter which way you do it. Okay, so this one, okay, so on this one we got the sixth term of the geometric. We know it's geometric. We want the sixth term, 1, 2, 3, 4, 5, 6, and it tells us that f1 is 7, that's the first term is 7, and this tells us right here, it says the previous number, it says to times it by 4. That's what that means. It means times 4. So we're going to times 4 here. We get 28 times 4 again, times 4 times 4, and do it one more time. If we keep going with that timesing 4, the sixth number is going to end up being 7,168. Counting the number of sticks, create the table, the graph, and the equation. So in this picture, you probably can't see the sticks very well because I've shrunk this picture down. If I take... Hello? Okay, sorry, I thought I paused it. If I take this picture and enlarge it, you can see that the number of sticks. So if we write our table, it would be